Okay, the first integral is, this integral is the integral of cos squared 5 pi z dz. Tricky enough integral. Just something to keep in mind is 5 pi is just a number. So 5 pi z is no different than having 2z. Okay, so 5 pi is 15 point something or whatever. So 5 pi is the exact same. So anyway, I'm going to do this by substitution. So I'm going to get u equals 5 pi z. And then when I differentiate that, you end up with du dz is equal to 5 pi, and du is equal to 5 pi dz. Now, not a lot of use to me for substitution for the moment, because I can't just swap out 5 pi here and dz for du, because the 5 pi z is wrapped up with this cos squared, but I can swap out my dz. So if I bring my 5 pi over, I get du over 5 pi equals dz. So I can replace my dz with du over 5 pi. So here I go, cos squared. Now 5 pi z I said is u, so cos squared of u, and instead of dz I can put in du over 5 pi. Now remember, 5 pi is just a number, so I can bring it out in front like that, times the integral of cos squared of u. Now, this is where it gets tricky. Us integrating cos squareds, anytime you have to integrate a cos squared or a sine squared or anything like that, it's not possible to do it straight, but it's not a terribly complicated solution either, but you just have to rewrite it. So you go to your tables, or to your formula book, and you'll see a formula something like this. Cos squared a equals a half times 1 plus cos 2a. And that's what we'll use to integrate. So we can swap out cos squared u. So I've got 1 over 5 pi times the integral. So instead of writing cos squared u, I got it a half times 1 plus the cos of 2u. That's a much easier integral to do. So again, I have my half here, so I can bring my half out in front. So I bring my half out of front. So half multiplied by 1 over 5 pi, top by top, bottom by bottom, is 1 over 10 pi. So 1 over 10 pi times the integral of 1 plus cos of 2u. Okay, so I'll integrate there. So I look for my integral of 1 is just going to give me, it's dz, yeah, so it's z's, isn't it? But this case I'm doing it with regards to du. So integrating 1, I get u, then integrating cos 2. So cos integrates to sine, so it's sine 2u divided by 2. Okay, so right, we'll put that together and then we'll bring back in what we know u to be. So I'll multiply in there 1 over 10. So 1 over 10 by u gives me u over 10 pi. And 1 over 10 pi by sine 2u over 2 gives me sine 2u over 20 pi. Okay, so now it's time just to bring back in our u. We said u is 5 pi times z. U is 5 pi times z. So 5 pi z over 10 pi plus sine 2 times, so 2 times u here, 2 times 5 pi z over 20 pi. Okay, now we can just simplify this out if we want, multiplying out our brackets. But if we want, we can also get a common denominator. So we'll do that in a second. Over 10 pi. And plus 2 times 5 pi z is the sine of 10 pi z over 20 pi. Now you could just throw your plus c in there, and that's absolutely correct as well. But if we just want to write it as one fraction, 10 pi and 20 pi, obviously 20 pi would be a perfect common denominator. So 10 pi would have to be multiplied by 2 to give me 20 pi. So I have to multiply the top line as well by 2. And the sine of 10 pi z is already over 20 pi, so that's just plus sine of 10 pi z. So just multiplying my 2 into that bracket there, I get 10 pi z plus sine of 10 pi z all over 20 pi. And I'm finished, so plus c.